Okay, I believe we are recording.
Okay. So just going to start quickly with show you a screen share of what we've been developing. It's very small. It's just to give you a sense of how active we've been on this. And we'll get back to it again later, but this is now, so can you see my slide?
Yep.
Yep.
Okay, you're not seeing the diagram anymore. Okay. Yeah, so this is, so the goal, as Damien said, was to discuss the upper level classes for the food processing ontology. And these objectives, these are actually some of the considerations that we had before getting into deciding what these upper level classes are. And also, as we went through these different objectives, we kept making changes to the upper level ontologies, either adding new classes, upper level classes, either adding new classes or changing the hierarchy. So these objectives are not in order of how we approach them. But if there's more questions, we can get to all of them, which we expect there will be. So the ontology does not include the does not include all of the words used in food jargon, like raw, harvested, then the more ambiguous words like fresh. But the ontology can be used to come up with a certain specification or a certain set of rules that give a generalized and unambiguous meaning to these words. And these are some of the applications. So all these could be in specific ontology adoptions. You could create food qualities such as food raw or food harvested, and then the classes in the ontology can be used to come up with a specification for what these terms mean in your context. This was actually an exercise that we started doing with FDs, and we're still in this process. You could see as we switch back to the ontology view later, we've got two foods called food raw and food not raw, and you could see a process. Then to clarify the differences between planned and unplanned processes, because we realize that there's a huge distinction between how food changes through various states. One is when you plan to do something, such as when you execute a recipe, whether that's done at home or in an industrial setting. And the other is an unplanned process, which is mostly a biological process. The fact that something which is raw then ripens, or it spoils, it gets rotten, or a microbe starts growing on it, whether that leads to a desirable result or not. And obviously, there is under the hood of the planned and the unplanned, there are many similar processes. So the context is important. The same thing, such as a fermentation, could be a sourdough fermentation, or it could be food rotting. So therefore, planned and unplanned would be this is the reason why the upper level classes. Then similarly, we wanted to clarify the differences between biological and physical-chemical reactions. Biological would be metabolic changes in a food through some living process. So a microbe is an example of that. Or it could be a metabolic change that's part of plant physiology. So both biological and physical-chemical could be in a planned or unplanned process. And you can see this distance, actually, we've already built this into the ontology. Then is again FTC specific, which is more general. So the objective above of differentiating between raw and harvested is one example, but more generally, we want to connect food processes to the qualities that they confer on food. These qualities could be simply things like frozen food or canned food, which is related to the process. The quality could also be a sensory quality of the food, which at the moment is not an FTC requirement, but that's also something that we've thought of. You might want to consider, are there any actually questions up to this point? There's only 2 more objectives. So far, if it's clear, then I could continue. Okay.
Tarini, sorry, I'm just curious. When you say planned and unplanned, so when you say unplanned, what do you mean? Is it by fluke?
Unplanned is just simply the progress of a metabolic process, unless you, for instance, if you don't want something to ripen, then you would store it in the fridge or in another inert condition where something cannot ripen.
Planned is human intentional. We're intervening
Mm.
in natural processes to slow them down or speed them up.
So
Okay.
plan is one type of intention, is that?
Matthew, could we wait till we get to the diagram? Because then I
Sure.
think for
Sure.
you and Ushashi, I think this would become much clearer. Yeah.
Okay. Yeah.
Actually, we can switch now because it just makes sense.
And just to say that unplanned processes like yeast fermentation in a biological sense can be harnessed by planned processes to achieve objectives.
Yeah, exactly. And you'll see that they are both like yeast or sourdough. You'll see that this is included in both places. Okay, so this is the upper level. I think those names are most readable, but we can zoom in as we start talking about it in your questions about certain classes. So at the uppermost level, going from left to right,
if you slide that menu to the right, to the left, then you'll have a little more screen space to show it all.
Oh, that's right. Yeah, thanks, Damien. So right, this is, so going from left to right is biological process, then physical chemical process, and then finally on the right is the plant process. So let's start looking at the plant process. As you see, there isn't an unplanned process, but anything that isn't planned could be unplanned. So plant process has two major subclasses: food transformation by mechanism or by objective. By objective is when you are transforming because you want to achieve a certain end quality. And the mechanism is a more general way of describing whether it's a form of energy, or it's the addition of a microbe, or it's the addition of another ingredient or chemical or any other kind of additive. And there could certainly be other mechanisms, so this is not complete. A complete ontology wouldn't fit into this. But like the mechanism could also be pressure, it could be frequency, so could be different kinds of radiation. So there's many more mechanisms than what's in here, but the idea is to basically have enough, show you enough classes so you can differentiate between these upper level classes. And that was one of our immediate goals, is to look at enough situations, look at enough examples of food, look at context of recipes or whatever, and come away with what is a representative upper level set of classes. So the other subclass is food transformation by objective. And again, this is not complete. So you zoom in a little bit more, sorry, into the objectives. Okay. So here you see going from left to right, food preservation. There's a variety of methods of doing that. Pickling the food, pasteurizing it, fermenting it, freezing it, homogenization. Again, you could homogenize with different kinds of energy, high speed or pressure, separating something into its parts, extracting, modifying nutrients, or sensory modification. And do you have any questions on plant processes?
Yeah, I have a couple of questions. I just want to understand what this is going to look like. So we made a few years ago, we made a processing, took a stab at making a processing
I know you, Matthew. You were at UC Davis.
Yeah, I know. I didn't know if you remembered that the processing ontology that we did, and
we didn't really work on it together, and I
right.
don't. I had actually taken a look at it.
Okay, so I think that there's some useful hints in there about this. We didn't do the planned process versus unplanned, but I think what's here is really cool. I really like the idea of having a stated objective. I guess when I was just looking at your example, trying to parse this out, so how is homogenization being an objective? I guess would be a question I would have.
Well, it is. Well, it's an objective. Whether you're making an emulsion, homogenizing milk is an objective,
right?
And it's also an objective that's very prevalent in the end product.
Yeah, there's going to be a polyhierarchy here. So some things that look like transformation by mechanism, the mechanism would be a mixer or some technology to homogenize, but homogenization itself may also look like it's a mechanistic term. So
fractional separation in the same way looks like a mechanistic term, right? And that's why there was actually quite a thought process between a lot of thinking that went into food transformation by mechanism and by objective. Like, for instance, is food cooking an objective or is it a mechanism? So I think these kinds of questions, they don't have a complete resolution, but they are very good questions. And we've used that to lead into what we have now
right
drawn out. Yeah.
So I'm expecting a polyhierarchy, but there's some more clear-cut examples like that: acidification and food pickling. And the idea of just exploring here is that a planned process can have a stated objective of a pickled food meeting certain criterion. That food pickling process would therefore have parts that reference more of a chemical transformation standalone process like acidification.
And you can see the polyhierarchy actually evident in a number of places, like food fermentation, which is a kind of preservation, would also come from food modification by microbe addition, right?
I would also be linked over to the left to the biological processes, which include,
exactly. So there's definitely a polyhierarchy. And then when you see here actually at physical-chemical reaction, that's when you go into a deeper level of the molecular reactions, because sometimes we know what Maillard reaction does, or we know why we need enzyme inactivation. And a lot of these, like roasting and baking, these processes, there could be other variants of this as well, like braising, and they all have inherent in them the Maillard reaction. So the idea of this is to also understand, if you're linking food products, and not if, when you link the food product to the process, then you want to identify how, or you link two variants of the product, right? Let's say a boiled version of boiled potato or raw potato. You want to understand the nutrient changes. And if you ignore the method by which it was grown, or you don't consider it in this case, then you know that the nutrient delta or compositional delta is due to a process. Now, you might want to know more specifically which process it was. So in case of boiling, it's quite simple. But let's say you have sauteing or some other process where there's maybe a bit of steaming happening, but then there's also a bit of browning. And you might want to know if the nutrient loss, or let's say the generation of, because it's not simply a delta, you might have new compounds in the final product that weren't there in the original product. So to look at, and I look at the reactions then gives you a more clear idea of how those change, I mean, at that level, of course, you're then looking at chemical composition and looking at reactions, which in a way are the constituents of a process. So this deeper level of physical chemical reactions, it has a place here, but it also then leads into more the inquiry of how a food really transforms.
This is great. Where does can you scroll so we can see the link up to Maillard? So, for instance, roasting gets you a Maillard, or as you said, any of those could potentially get you a Maillard, but a Maillard reaction only happens if there's protein involved. So where is the intersection between, like, if you only have sugar and you're heating, you're going to get caramelization, right? So you're not going to get a Maillard reaction. So where's the role for the ingredient in actually impacting the actual reaction that's going to occur?
So as you see now, this is being a process ontology. It doesn't really have the ingredients or the chemical components. But as you could see here, we've got a number of foods, right, that we've connected to processes. Now, similarly, you could have a number of chemicals connected to reactions, and then that would get you what you're talking about. So it's definitely an application. I'm not sure if it inherently belongs in the process ontology, but I think this is also the starting point for how it can be used. So what you mentioned it's part of my PhD work. That's what I'm doing.
And I'd add that every blue box is a process, every green box is a material entity. We can mandate that processes output material entities, or that material entities are inevitably the output of a process. But we can also do the same thing for inputs, where we know that a Maillard reaction requires what you just mentioned, then we can put that as a necessary input. And I am interested in modeling in FoodOn to that level, the material dependencies and also the informational outputs for each of these processes, to the extent that it's easy and simple and that everyone can agree on it.
Right, exactly. But like this is also, I think that this would be useful also in for a recipe ontology, because there's certainly a lot of terms here that you are all visible. You might not see, mechanical force or something, but then there'd be subclasses of this, like chopping or grinding or whatever, which you would find in the recipe ontology. So it's a starting point for many such uses.
I'm thinking that I'd say a starting point, and I think that it could be merged with what we've developed already for processing, in terms of we've actually sort of identified a lot of those things, and I'd be happy to contribute that to your effort.
Yeah, I remember the hierarchy of terms, and indeed it's all about at the moment the upper levels, trying to get them in place so that it's easier to drop stuff underneath them.
Right.
I'm interested in Larisa's take, knowing that coming from a laboratory protocol perspective.
Yes, I have a lot of thoughts about it. No, first, it's indeed, so questions that you are asking are very similar to questions that we are asking. Yes, you can model differently. You came up with this way, and I think it's absolutely fine. So you just have to make decisions this way or that. And I don't think there is any optimal way. But my main thought is try to scrutinize it from point of view of automation and machine learning, like all applications when robots are cooking. So how it will work for them, or all these data sets about food, so more and more requirement to annotate these data sets, so they need these labels so you can do machine learning better. So I would like to think more a little bit about it. So for me, it looks like you're doing all the right and wonderful stuff. I really love it. But it will go down to these use cases. And I just really ask you to remember about this use case when it's all will be used for machine learning and by some AI agents.
Right. So for the robot cooking, I think that you need a sequence. So just to know that like food is, pasteurization has part heating is not enough, because you need to know how long it's been heated to, what temperature it's been heated to. So that's such details. So at the moment, there isn't really an execution, and I think Damien has an here, right? Plan process executes a plan specification. So a plan specification would have those details for a robot cooking sequence. But however, at least, with this, you have a standard set of terminologies, and the same terminologies could then be used in the sequence along with such sequential information about time, temperature, process, equipment as well, right? So that's sort of a start to your question on robots cooking. About machine learning, there are many applications, and you could, I also work in creating and automating ontologies through a data-driven process. So that's an example of machine learning, where a machine would learn, if this is all the ontology we have, then a machine would learn this. And by learning, I mean the placement of the terms, the hierarchy of the terms, and read over food science, food engineering literature, extract other process terms, and then place them into this hierarchy and for then manual verification and then, acceptance of it. So this definitely, even at this point, with whatever we have, you could use machine learning to add more to the ontology.
No, I don't say that there are gaps or whatever. I just think that it would be really good to try to check it against such use cases. So for example, food nutrition security. I know that Damien also is participating in this project. So they have very rich data sets and very specific tasks, and they are representing these data sets directly being suitable for machine learning processing. So, what I would like to do, just go back to the data sets and see if your label what you have right now will be sufficient to capture information what they need or not. So maybe just such use cases can give a little bit more directions, but I guess that you're already fine. But this is just something to maybe.
Sure. We, like I said, we could go back to that objective slide, but those were the use cases that led us to this. I think the one thing we thought to not really bake into this is like things like food safety. So I don't know, like that use case. I mean, like, well, for that you could, for instance, like we've done here with food raw and food not raw and food raw, you could do things like, so like food safety, for instance, that's not something we want to build into the ontology, but you could use the ontology for that use case. Nutrition security, I don't know what you mean, but I'm sure it's definitely a use case.
Okay, great. No, honestly, I love what I see.
Great. And, so we can talk another time a little bit more about details, but I'm just borrowing in this diagram, we're just borrowing a few components of the whole OBO Foundry OB world around processes. But I believe so far, all that we've sort of taken is actually easily mappable to other people's process ontology stuff, because we haven't gotten into the the details of how to exactly record those experimental or culinary kitchen parameters for doing the food processing.
Can I ask a process question related to the process of this group? How do you want to move forward in terms of people bringing in ideas, people knowing about other resources that are out there, you know, inviting new members? How does this group gonna work?
Right. So far in my head, it's been kind of informal. And so anybody who's interested, come on board. I guess I'm trying to parameterize it that we're just looking at the top level terms right now, trying to focus on the questions that bulletproof our choice of the top level hierarchy, which then my own greedy takeaway is that I can go and implement that in FoodOn. And the underlying set of over 200 food processes that are there can then find slightly better home than they have right now, or a much better home. But that's my objective. And I recognize that other people in the group will all have their own objectives and needs. So I'm happy to try to accommodate that more in beyond what might be stated here. And that would be something to talk about, to hear from you guys. It's a delicate question in terms of a volunteer effort about how to coordinate energy around any particular person's mission or agency's mission. But this is the place to talk about that.
Well, I'm also cognizant of the fact that, you know, this is, as you say, your PhD work, Tarini, right? So there's a certain amount that you need to own for that, I guess, or how does that work?
This is not it's related to my PhD work, but so far this came out of our project with USDA. So I think that there is, and most of our conversations have happened there. So I don't know that I'm about to give any clear answer about claims to this project. I suppose some of it has to do with time invested. But on the other hand, I think if the goal, as we mentioned up here, is coming up with upper level classes for the food processing ontology, and we know that these could be used in a number of ways. And FoodOn isn't going to cover the full extent of the food processing ontology and its capabilities, but never was the place anyway. And so, similarly, as the nutrition security use case that I don't know anything about, it would use this and then, in their own context. So I think it would be interesting. And so going on with like these objectives, you might want a range of parameter values for the transformation mechanisms. For instance, is there a temperature range for processes related to the removal or addition of thermal energy? Or any associated phenotypic variations. So if you apply X amount of a certain energy, how does that change the phenotypes? For instance, the grinding size or something, the mill size, or one of the other things which we thought, which is not so use case specific, is to identify which processes are not only for food. So to keep it as general, since we borrowed also from OB, it makes sense to see here which ones could be applied in other domains.
Right.
So to answer your question, Matthew, I think that if we're all working together, then maybe we come from all of our different objectives and create this upper level classes together.
Mm-hmm. And a slight gap in OBO Foundry right now is that there isn't a sort of general material process ontology. And I think in the future, the IOF, the Industrial Ontology Foundry, might have people that would want to take that on. But in lieu of that, we had I've been talking with Larisa about moving exact2 into the OBO Foundry. And so that would be a possible standalone ontology for general process terms that, of course, are laboratory and robot friendly. But Larisa, I believe you're also open to trying to create a little bit more of a joint effort.
Absolutely, absolutely. Whatever is sensible. I completely agree that there is a need for such an ontology. I'm surprised there is still no one has done it. So, yeah, whatever way is easier, I'm on board.
Right. So I do come in with a strong OBO Foundry bias, but people will be interested to know, and I can talk in an upcoming session about the fact that the OBO Foundry Old Guard and New Guard are actually creating a new ontology called COB, which is meant to fit a little bit lower down than the BFO, and in fact doesn't necessarily have to depend on BFO. And why this will be attractive is visible practically in a single slide, which is that when you arrive at the COB ontology, all you see in the top level are material entities, processes, and information, and then maybe one other upper level thing. And those are easily accessible terms. And the vision of COB is that it might be a new mid-level ontology that all the other ontologies can slowly bring in because it's got all the common parts. So what I'm winding around to is that a process ontology would fit very nicely under that without scaring people off about the whole BFO abstraction and possible incompatibilities. So there's a change and a generalization that's happening there that might really benefit this idea of a general process ontology.
Well, I'll just say, what we did develop, and I'm happy to also share in a future meeting or anytime I could, throw it up on the screen now. But the general process ontology classes that we've developed are already BFO compliant. In terms of being an occurrent and whatnot, according to BFO hierarchies.
Well, what I'd add is that's in itself sounds easy, because if they're processes and they're in a hierarchy, then they fit under the word process in BFO. Where things start to go sideways is if you have a lot of axioms attached to them. As I recall, your hierarchy doesn't have any axioms involved. Other than
not
stuff?
Yet.
Right. So I much appreciate comparing your hierarchy and seeing how we can adjust it in this whole notion of splitting up processes into biological ones and physical, and
why don't I share my screen
around planned processes.
Right. Why don't I share my screen for 5 minutes, and then I can give you guys the link that's up at the GitHub.
Mm-hmm. Yeah, sure.
Okay, great.
And Warren, do you have a comment? You have your hand raised, is that right?
Right. One of the comments, so the Millard process was mentioned, which is really interested in the concepts of malts. I'll second the comment that we need to worry about parameters and temperature and amount of time for that sub-process. But right now, what I'm seeing is a plan specification. And we all know that in the real world, there's the plan and then there's what actually happens, and the two sometimes actually meet.
Mm-hmm.
So my question is going to be, how are you going to represent the plan, and how are you going to represent the recording of what actually happened according to instrumentation?
Yeah, so this is an example of where certain of you may drive a more detailed process model that goes beyond the naming of a process and its possible inputs and outputs, and actually gets into the realm of more detailed measurements and observations and so on. And I know PO2 folks, you'll have some comments about that, because you have a working system for capturing the observables in an industrial context. So That is pushing the project towards process modeling in more detail, and I'm totally open to that. What I'd like to see is a first pass, though, personally, that gets at the hierarchy of process categorization, and then can start to work on what are the actors, the participants, the resources, the kind of energy, the timing that one would want to start modeling different areas of that around.
Can I answer that question?
Mm-hmm.
Because yes, I had it many times. So plan specification, it's actually information content entity in terms of IO. So it's just piece of information. It's your plan specification, whatever. And we're talking about processes, about what actually happened. And recording about processes, again, is information entity. So again, how you represent, how you record, that allows this clean separations. And this part, processual part, I agree, never was really well represented. So, and that is why I so like this work.
I see. Right. So in OB, there was a fair bit said about these plan specifications at a general level, but they never got around to a detailed level, especially one that requires feedback, which is exactly what automation requires, little feedback adjustments to plans and recovering and recalibration and all of that kind of stuff. None of that is in the OB world, because it was driven by biomedical kind of stuff and not manufacturing. Okay, that said, I suppose let's frame it this way. All of these questions are coming up. They're coming up full speed. I need to open up a document so that we have a call log and can hold on to these questions so that they can become a floating agenda if we don't get to them in a particular session. And so I will move to do that. At the moment, I was recording some notes in the food ontology discussion group, but it sounds like we might as well peel this off into a separate call log. So I'll do that. So that said, I think back to you for 5 minutes or so, Matthew, and then
Yeah, it won't take long.
Okay.
For those of you who would like to have access to what I'm showing you, I put the URL in the chat. And this is, I haven't looked at this in a few years, honestly, but we did break things down according to process. Looking back at it now, I see that in fact things like cleaning process would, I guess, be under one of your intentional planned processes where we could sort of change that. But we did break things down in terms of the types, biological, chemical, and then certain types of physical. So this decorticating process would be a physical process, which is the removal of an outer layer. So these type of things happen in food all the time. The chemical process, in some ways similar. We just listed out a few extraction type processes where you want to pull something out. Which would be, you could also call that a chemical separation process. I think where we did highlight some of what we were thinking of in terms of planned was in a manufacturing process. So cleaning and manufacturing being quite separate, but both necessary processes that you need to do when you're dealing with food, which I guess would both be under planned processes. And then just as you were showing, there's sort of this multiple parentage, right? So this biological manufacturing process would include a fermentation, so a planned fermentation process, as it were. And similar with chemical and probably things like psychrometric, which are around essentially humidification and dehumidification. And then various other types of mechanical processes here. I would probably go back and put decorticating under mechanical, but various ways of putting air into something so that you could create a foam. So thinking back to the other graph that we just looked at, I would probably see emulsification, which is the combination of lipids and non or polar and non-polar things together would be an emulsification, but a foam would be another sort of outcome you would be looking for, which would be putting air inside of a liquid. And then various types of separation processes, which probably decorticating would be a type of separation process, going back and looking at this now.
That's how we represented it. I think quite a lot of what you're showing here, Matthew, would fit very nicely under the upper level classes that we've defined. And there's a lot of multi-homing potential here, which, as you said, you haven't spent years on this, but there's a lot of multi-homing potential, which I think, I mean, there's certainly a few cases there that we may not have covered, but I think there's quite a lot that would fit nicely in the structure we have.
Cool.
Appreciate the whole food science perspective on this, which carries into the manufacturing side. So yeah, looking forward to incorporate that. I believe everybody, we're content with the 1 hour, is that right? I think that's about a good amount of discussion time. So it'll be a question of how to both handle the detailed hierarchy. Like I have the same sort of thing in FoodOn with a hierarchy that I need to massage into this new platform. But what I'm interested in, if we could go back to the diagram, Tarini.
Yeah, I think, can I just share? Oh, you have to stop sharing, Matthew. I can't share it while you.
I see. I'd like to focus on the upper level questions. And so Tarini left a few notes in here as examples of questions to challenge this hierarchy. For example, can we really fit all biological processes? Metabolic processes, are all metabolic processes biological, and or are they the same thing? And are we not capturing some stuff that we need to capture at this second tier? I sort of put 2 tiers in this diagram, and so a question in challenging this hierarchy is whether this second tier, that at the moment has food transformation process as a node, is sufficiently granular or not, or we need more categories there. And whether food transformation by mechanism gets to be multi-homed right there or not, for example. So these are all things that I think could occupy some discussion time in the future.
Yeah. Yeah, same thing. I was going to say that it's great to see other like Matthews, but if we could come back to this upper level structure, then that seems like something that would be beneficial to everyone. Would that be a goal?
I agree, Tarini. I agree. I mean, what I'm trying to understand is, one, of course, whether everything has been captured. And also the other aspect is the modeling bit, which I am really interested, and I'm trying to see whether we are trying to have everything under one umbrella, and also try to get them organized. So, so this is also my interest. Yeah.
Okay. Sounds good. Okay, I will prepare an agenda that everyone can contribute to make sure your issues are on, prioritized at some point in floating or in a particular session. And that will take us to the next call, which I believe would have to be in through 3 weeks or a month. I'm not sure. I'll check on that for this slot. Anyone else want to make finishing comments here? Are you generally happy to be part of this group? And if not, do you need to make some demands in order for your time to be useful here? I can also throw that question out there. And it may well involve presenting a bit more of your group's take on what you need out of or where your work is at and what you need out of it. I know, Babak, you were thinking of being able to present about some food processing work you were doing, but that you need to publish first. Is that right?
Yes, yes. So we are not done completely with manuscript. I think in a few months, it will be submitting it. So once we're there, I'm gonna definitely present that work.
Okay.
And also, if you guys want the unmapped complexity of the food, the paper that's already out there, I can talk about that too, but that's not related to the processing.
Okay. Okay, well, maybe for the general food, diet and nutrition group, that might be pitched a nice presentation.
Yeah, that would be totally fine. We can, exchange some emails, make a plan for that.
Okay. Great.
Just one question, Babak, but I can email you separately as well. I was just wondering if you're working in processes in whatever your project is, where are you getting the terminology or the process nomenclature from?
So
It's just from literature?
One thing that I wanted to tell, might be interesting in the future is also contamination as well to include. For example, furans, they are byproduct of putting hot food and can it while it's hot, and the furan stays there. And so that's because of the process.
Right. Actually, I was going to along with the Maillard reaction. So in this section here on molecular reactions, so certain chemical reactions act in a bulk mode like gelation, but then there are molecular reactions, and the furan reaction is similar to the Maillard reaction. I mean, it requires some of the similar conditions. And so that molecular reaction section will expand out to contain it, but that's sort of much more detailed. So at the moment, but it feels like the home for it is right one, this upper level class.
Yeah, so what we do is more like in epidemiological and machine learning part right now. So
Okay.
in the future, we might get into actual processes as well. But contamination itself has been broken down into multiple stages. It can be related to storage, it's related to transportation and all that stuff. So, and that's a big problem with processed food.
Okay, great. Well, so glad to have all this talent on board to help steer us and avoid the potholes. So I will, let's adjourn and look forward to seeing all of you back who find it useful for the next session. Thank you all.
Sure. Awesome. Thank you.
Great.
Bye.
Bye.
Thanks, Damien. Thanks, everyone. Bye.
Thank you.
Bye, everyone.
Bye.
Bye.